Grey Kangaroo 2022. It's the intermediate math extension for year 9. Really well done if you were invited to take this, and if you weren't, or if you were just in the wrong year group, maybe you can just use this video to try some of the questions and see how many you would have got. Question number 1, so we're just kind of arranging these tiles here to make the smallest number total. Now, of course, to make a smaller number, we need to start with the smallest digits, right? So we'll start with the 107 because that has the smallest leading digit, and of course the digits are worth more the further you go along. The next one with the smallest leading digit is this one here, 31. Then we go to a 4, then we have a 59, and then finally the number would end in an 8. And so that would be the answer. Question 2. So this kangaroo jumps 3 and then 3, and then it does little ones, and then it goes 3 and then 3 again, and repeats those little ones. So it hits quite a lot of numbers, but the first thing to say is that it hits every multiple of 3, because it either jumps 3 and then does some little ones, but it hits every multiple of 3 because it just goes again. So just check, any of these are multiple of 3? Well, yeah, they are, because they're all consecutive and there's more than 3 of them, so one of them must be. It's 84. I can tell because the digits add up to a multiple of 3, which is the classic test for divisibility by 3. Question number 3. I hope at this point all that everybody who was actually taking this for real did was turn the paper upside down to see which one was the same. Of course, I can just copy this image and turn it upside down and see that E matches pretty perfectly, and so the answer is E. Question 4. Just trial and error this. You know, you're supposed to put 4 plus signs and a negative in here to make this work. Just try it out. You know, just try it. 15, 27, 42. This ends up not working. I can't be bothered to actually do it, but it ends up not working. Just put it somewhere else, and this ends up actually working. So 15, 27, 43 is actually, take away that, plus 21, I think you get 20, plus 21, or 24 actually, plus 21, 25. This ends up working. Just try it out, not too complicated. Just don't be afraid to just sit here and try things. Like, it's a guaranteed mark. All you have to do at most is try 5 different things. You're eventually going to get it. Just try it. Question 5, so we want these paths here, these 3 paths, to have the same number of trees either side of them. So if we look at this north-south path here, it has 2 trees to its left currently and 3 to its right, which means that we need to plant another tree in either section A or B to balance that out. But if you also look at this east-west path here, that has 2 above it and 3 below, so the tree must be planted in B, C, or E to make that make sense. But of course, if it has to be here and it also has to be here, then that means it must be in B. And you can also verify that this path also makes that work, because it's got 2 above it right now and 3 below it, so B would make that work fine. How many positive integers between that and that only have odd digits? Well, okay, none of the 1 zeros work because 0 is an even digit. So the first number that's going to work is 111. That, of course, is followed by 113, 115, 117, and 119. Then none of the 120s work, because obviously the digit is a 2 here. So then the next ones are the 130s with the same digits at the end here. So every time we have an odd second digit, we're going to have 5 numbers that will do this. So that's going to be 5 times 5, right? Because there are 5 odd digits to use in the second digit, just like there are 5 odd digits to use in the third. You can list them all out if you desperately want to. That's 25 numbers between 100 and 200. Of course, once you get to 200, nothing will work because they all start with a 2. So it's just going to be the 25 in total. 300 doesn't count because it has 2 zeros in it. So yeah, that's it. Question 7. So dice have opposite numbers adding to a 7. So 1 is opposite 6, 4 is opposite 3, 2 is opposite 5. That's how dice work. What's the minimum number of pips that could lie on the whole surface? Well, for a minimum number, we want, the surfaces we can't see are these ones in here. So we need to make those as big as possible. And likewise, we need to make the thing we're actually counting as small as possible. So we need to put a 1 over here and a 1 on the back of this here, which of course necessarily means that there'll be a 6 on this dice's other face over here. 1 plus 6 is 7, and a 6 over here as well. So that's good. We're hiding the 6's, which will minimize our outside numbers. Not really sure what to do with this middle one, but it doesn't really matter actually, because whichever 2 faces you hide of this dice here, you're going to be hiding a total of 7, so it doesn't actually matter. Let's just pretend we hide a 6 and a 1. It doesn't matter though. Whichever you hide, you're going to be hiding a 7, and likewise here, just hide a 1 and a 6. It doesn't matter because you'll always be hiding 7 in total anyway. And then we can just add these all up, right? All dice faces add up to 21 because it's 3 pairs of adding up to 7. Is one way to think about that, or just do 1 plus 2 plus 3 all the way to 6. And then we're going to be hiding 6, 6, 1, 1, 6, 6. And we can add that up and we get a total of 58. Number 8. So these are the tulips here, these are the daisies. What's the total of the regions that are daisies, so these two regions here. Many ways to do this. The total square is 12 across, 12 up, which makes this point here, because the whole thing we can clearly see is symmetrical, this must be the midpoint of the square, which means it's 6 up. And now, you know, this kind of question comes up a lot. Finding the area of kites is quite annoying sometimes, but it's not that bad because you can just split it in half, and you can say, actually, all I want is this triangle, and then I'll times this triangle by 4. And this triangle is just height 6, base 4, so it's going to be a half times 4 times 6, and then you times all of that by 4 because there are 4 of these regions to make the total area that we want, and we get the answer of 48. Question 9, 3 sisters. Okay, let's call the sisters A, B, and C. Have different ages, but the average is 10. So the sum of all the ages is 30, because 30 divided by 3 is 10. The average age of one pair of sisters is 11, and the average age of the other is 12. Now let's pretend these sisters in order of age, smallest to largest. The average age being 12, the two that have an average age of 12 must be the oldest two, and the two that have average age 11 must be the oldest one and the youngest one, because both of these numbers are bigger than 12. So what must be happening is the average age of the last pair, the two youngest, must be quite a long way below 10 to make this all balance out. So B and C must add up to 24, because 12, or 24 divided by 2 gives you the 12, and C plus A must add up to 22. Again, 22 divided by 2 is 11. And we can use this to work out the answer here. If we just do from here, if A plus C is 22, then these two make 22, which means B must be 8. To make the top sentence work, you can just do kind of this, take away this one, this sentence, take away this one. If B is 8, then that means C is 16, clearly. You could work out what A is if you want to, but C is the older sister, and she's 16. So the answer is 16, which I don't think I even bothered. Nope. Okay, it's there, 16. Question 10. Two 24-hour clocks. One clock gains every minute an hour, so that one's fast, and the other one is slow by 2 minutes. And apparently you set them at the same time, and then at some point one is exactly an hour ahead of the other one. Now every hour that these clocks are on, one gains 1 minute, the other loses 2. So every hour the clocks fall 3 minutes further apart, because one goes ahead by 1, the other behind by 2, which means we want the clocks to be 60 minutes apart. So let's times this up by 20 to get 20 hours the clocks are 60 apart. So that's the first thing to find out, is that after 20 hours the clocks drift apart by an hour. Okay, good. So when do you set the clocks then? Well, the other thing to consider is that the faster clock, which is of course going to be saying 12, is actually ahead of real time. After 20 hours, it's ahead 20 minutes of real time, which means real time is 11:40. But all we have to do now is say that, okay, so real time is 11:40, this clock is 20 minutes ahead, this one is 40 minutes behind. But you did this 20 hours ago, 20 hours from real time ago. So you just take 20 hours away from this. Easiest way maybe to do that is to add 4 hours to it and then take away a day. So you get 15:40 the day before, which, yeah, is the answer. Question number 11. Wrote a list of numbers with a sum of 22. So wrote a list of numbers. N is the 14th number in the alphabet, but I'm not saying this is necessarily a list of 14. N just represents the nth one. Don't know how long ago or how many are long. A list of numbers adding up to 22, which means I think I'll write the next statement out in a second. Sorry, I'm just going to move the mic. Slightly annoying. Sorry, cheers. Anyway, next person subtracts 7 from all of the numbers. No, they don't. They subtract each of the numbers from 7. Just read that the right way around. So it's 7 take away this is the number below this, 7 take away that, 7 take away that, and so on. And those all add up to 34. So now we can just write 7 minus this, plus 7 minus this, plus 7 minus this, plus 7 minus this is 34 with some dots in between. And now the nice thing about adding and taking away is you can kind of do it in whatever order you want. So let's just add all the 7s together first and then take away all the letters. But this factorizes quite nicely because you've got, well, how many 7s here? Well, you've got n of them. For each of the original numbers you have 1 7, so this is 7 times n. And this here we can factorize to just be minus all of the original numbers added together, but all the original numbers added together are 22. And this is just a very simple solve now, and we get n is 8 numbers originally. Quite a nice question. 12. So we've got all these numbers are going to multiply to give us the numbers they're pointing at. Now I started at the top and I said, how do I multiply 3 numbers to make 30? Well, I could use either 2, 3, and 5, or I could use 1, 6, and 5. And at this point, you just get your pencil and you get prepared to rub out something if it's wrong. You just choose one of these to run with. If it works, great. If it doesn't, oh well. I chose to run with this one first because I noticed that the 1 has to go somewhere, and it would make sense for it to be on a path with the 2 smallest numbers. So I put a 1 here because I figured that, okay, I can make it a path here with this one, because those are the 2 smallest. Also, 1 times 4 times 7 does work for this. So that gives me some hope that this is a good place to put this. Of course, the only other way to make 28 actually is 2 times 2 times 7, but I don't have 2 2s. So actually this is the only way to make 28, which means the 1 does actually have to go here. We have to choose this one. Okay, so where does the 6 and the 5 go? Well, I can't put a 5 here because neither of these numbers are divisible by 5. So the 5 has to be here and the 6 has to be here. Okay, and now let's just figure this out. So which way should the 4 and the 7 go? Well, okay, 7 can't go here because 6 times 7 is 42. That's not good. So this has to be the 4, this has to be the 7. Then we can fill in the rest of it quite easily. 6 times 4, and this makes this a 2. 5 7 is 35, that makes this a 3. 18, and then the last number left over is the 8. That makes 144. And so the sum of the last digits is 9 plus 8, 17. 13. So 45% is the intersection of the triangle and the circle. So that's this area here. That's 45% of the diagram. Outside the circle is 40%, so that's this area here is 40%. Now, of course, 40 plus 45 is 85, which means 15% of the shape is left, so that must be down here, 15%. What percentage of the circle lies outside the triangle? Now, just be careful, it's what percentage of the circle? So I'm not concerned with anything else, I'm just concerned with the circle. What percent of the circle is here? Well, it's clearly 15 out of 60 of it. Because the total of the circle is 60, the bit here is 15. 15 out of 60 is 3/4, which is 25%. Just be careful to not say it's a third, just because this is a third of that. It's a quarter, right? If it was 1 to 3, then it would be a quarter. If it was 1 here, 3 here, it would be a quarter because you've got 1 out of a total of 4. So just be careful to not mix up fractions and ratio. This is quite a nice question, quite an interesting one. Apparently you want all of the 2 by 2 squares to add up to the same thing. Now, it's not very specific about what it wants you to add them up to, and it also doesn't give you any restrictions at all about what numbers you can use to put in here, and the fact that it's so unrestrictive just means I can make up whatever I want. So let's just pretend that we want the sum of all the 2 by 2 boxes to be 4. That means that I need to put zeros all the way around here, which would mean a 2 gets put here, and that makes this box and this box add up to 4. That means a 1 has to be down here clearly, and then of course this box would just have to be a 1. And there's nothing in the question that says that I can't just do that. And that answer works, so it must be the answer. Cool. Question 15. Quite a few drawings to do here. So you got a line with 4 towns, you don't know the order of them. P and R seem to have to be quite a long way away compared to the other distances. So let's put them a long way away, 75. And then let's put Q and S in between somewhere with a distance of 45 in between, like this. Okay. Now, the distance from Q to R is 20, so that's down there as well. Now here, the distance from P to S, well, it's just 75 minus these two, which is 10, sorry. Which means 10 is an answer that I can have. Now, how can I have the other answers? Well, it just depends in which order you put these towns, right? So again, starting with P and R like this, what happens if you, instead of putting both S and Q in the middle, what happens if you put, say, S over here, and then Q the other side? And now follow all the rules, so Q to S is still 45, and Q to R is still 20, but that makes this distance out here, 45 take away 20, which is 25, and then that makes the distance from P to S 75 plus 25, which is 100. So I can make this one as well. And so now I've got Q and S in the middle, I've got Q in the middle and S outside. So now let's put S in the middle and Q outside, and then let's put them both outside. And that was my kind of logic. So this time S in the middle, Q outside. Again, just do all the distances, find out which one you get, and you get this one here. And then you put both out on the other side of P and R. Again, find out which one, just do some maths, draw it out, and you get 140 as your distance. Makes sense, that's the longest one. And so 80 is the one that I can't make of the list. Good. Question number 16. Very similar question in the pink kangaroo to this. Label your rectangle X and Y. So this length X, this length Y. Do it all the way around. And then say, well, okay, according to because this is a rectangle, this side equals this side, so 4x equals 3y. That means x equals 3/4 y. So let's replace all of these x's with 3/4 y's. Oh, in fact, okay, so this is what I did. I replaced this one with 3/4 y, which makes this length 1 plus 3/4 y, and this one 3y, and then the ratio is just this to this. So 1 to 3/4 y to 3y, cancel the y's, and then maybe actually change this to an improper fraction, which I should have done right at the start. I was just being super lazy. Times everything by 4, and you get the answer of 12 to 7. 17. So we just need to rely on a rule here, which is that evens plus even are even, odds plus odds are even. The only way to make odds is even plus odd, or odd plus even, of course, that's the same thing. So, okay, let's just make a list of numbers. Let's pretend they're all even. Now, any sum of any pair here is, of course, going to be even. So you're going to get 0 odd numbers from this here. So, okay, what if you make one of the numbers odd? Well, here, you're going to get all evens except for this sum, and this sum. So that'll be 3 odd numbers. Okay, 2 of them odd. Well, okay, now they're going to be, the odd sums are going to be this one, this one, this one, and this one. That's 4 pairs. And then when you've got 3 odds, it's actually symmetrical to this one. The only odds are going to be even plus this, even plus that, or even plus that. And then 4 odds is actually just all going to be even. So the most what you can get is 4 by using 2 odds and 2 evens. Cool. 18. So this is the one question that I'm not happy with, because I found this question really hard, and I've done it in a really, really difficult way. Hopefully the mark scheme will come out in a little bit, and if you're not okay with my method, you can maybe look at the mark scheme. They've probably done something much more intelligent that I just couldn't see. But anyway, let's try it out. So we'll call the distance from home to school D. So the distance from home to school is D. We'll call that to start with. It takes 26 minutes to get home to school. Of course, 52 minutes is the total there and back, so we'll just say 26 minutes there to there. Eva is, her house is somewhere along this journey, and he does the first bit by bike and the second bit walking, is the idea. He cycles 3 times as fast as he walks. We can just tell by this. So if I call his walking speed x, his speed while cycling must be 3x. Okay, so if I draw arrows in here, that's 3x is his speed to here, and then x is his speed thereafter. Now, using what if speed equals distance over time, his speed to do the entire thing cycling is 3x, and that takes him 20 minutes. And so 3x equals d over, sorry, that takes him 10 minutes, doesn't it? It takes him 10 minutes just to do all of this bit by bike, 20 minutes to go there and back again. So 3x equals d over 10, which means d is 3x. So let's replace that there. Now, I got a bit stuck here for a while, but what I said was, let's pretend that he goes to Eva's house for some time t. And that makes, if it takes him time t to get to here, it takes him time 26 minus t to get to there. And now doing more speed equals distance over time, just looking at the parts individually, here the speed is 3x, the time is t, which means distance is 3x times t, just cross multiplying that over there. And so this distance here is 3xt, by using distance equals speed times time, speed times time. And here again, distance for this bit is speed times time, which makes this. But now I have that this plus this must equal that. X's are everywhere, so just cancel them all out. And this solves for t quite quickly. And so the time he takes to get to Eva's house by bike is 2 minutes. Well, how far does he travel in those 2 minutes? Well, he travels 6x distance, just replacing this t with a 2. And replacing this t with a 2, you get 24x. And so the ratio, or fraction, sorry, the fraction of the journey by bike is 6x over 30x, which is a quarter. Ooh, hang on. What have I done here? I've actually got this wrong right at the very end. Apologies. This should be fraction of the journey. This is just like that question before, isn't it? You do fraction over total, so it's going to be over 30 here, which means a fifth of it is done by cycling. And so this is the answer, a fifth. Yeah, just made a small mistake at the very end there, but I'm sure it's a fifth now. A fifth of it is done by bike. I think. I hope so anyway. Otherwise, I'm going to be super, super annoyed. Question number 19. Okay, so much more gentle, nicer question again. So let's call some surfaces here. Let's call this rectangle at the top A. Let's call the rectangle on the side B and the rectangle on this side C. Now, what we can say here is that this thing here is, let's break apart the two cuboids and say that this whole thing is 2 surface areas, or looking at this one I guess first, minus the 2 A's that are covered up, and that equals 72. So if you just took these apart, it would just be 2 surface areas. But you're slamming them together to lose these 2 A's here. So it's 2 surface area minus 2a, so 72. Same thing here, 2 surface areas minus 2b, and here 2 surface areas minus 2c is 102. Now let's just write those all out and add them all together. But when we factorize this, 2a plus 2b plus 2c is the surface area. So this is essentially 6 surface areas minus 1 surface areas to get 5 surface areas, divide by 5, and you get surface areas 54. Here, by the way, I just added all these together to make this, if it wasn't too obvious. But yeah, that's question 19. Question 20, Carl wrote a list of 10 integers on the board. Each integer is a multiple of the previous. So let's just try this, because this seems really hard and as if you haven't been given any hints at all. But if you start with 5 and then write a multiple, 25, then write another multiple, 125, then write another one. The problem with this is the numbers get very big very quickly. You're supposed to use 10 numbers. I hope you can appreciate with multiplying, the numbers just get bigger and bigger, faster and faster. I'm only 4 numbers down and I'm already basically here. So this is a problem. So let's start with some very small numbers to try and offset that. Let's just go 1, 2, and let's also not only start with the smallest number we can, but let's times it by the least thing we can every time. So essentially just times it by 2 every single time. If you do that, you eventually make this list, which you might know because it's just the multiples or the powers of 2. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers written on the board. So that's good. Except we're not at 600. So we've gone slightly too low. So all I'm going to do is do the same list, but just times one of them by 3. In fact, I'll just times the last one by 3, because I can actually see if I do that, I'm going to land between here and here. So here's the answer. Now, how do you know that's the only answer? Well, I sort of don't at the moment, but it doesn't matter, right? Because it's an answer that's definitely following the rules, so therefore it's the right answer of the list. If you wanted to prove that it was the only one you can make, then you can do that, because when you use this system of timesing one of the numbers by 3 instead of 2, it actually doesn't matter which number you choose. If you times the first one by 3 instead, then start timesing by 2, you end up at the same place. You can do some algebra to prove that, and then actually if you do the next thing, which is to times 2 of them by 3 instead, you end up being too big. So I've times the first one by 3, and then I'm going to times the last one, it looks like, by 3. No, which one did I times by 3 here? This one here, I just randomly chose times by 3, then by 2s again, but you end up too big. So 768 is the only valid or possible thing you can get here. 21, so 1 by 4 rectangles or 4 by 1 rectangles all need to have at least one kind of dot in them coloured. So okay, if I just colour this dot, one of the ways that I thought to do this was, let's just pretend that this is a 4 by 4 grid instead of 5 by 5. Then the dots I would have to colour are this one, this one, this one, and this one. That's the minimum number, because now I'm covering everything vertically and everything horizontally. Now I'm not covering this outside section, so how do I cover this outside section too? Well, I need to cover something in this 1 by 4 and something in this 1 by 4. So let's do this one here. And then likewise for this, I need to cover something here and something here. So let's do that one, and then likewise up here, just need to cover this and this. So we'll just do that one there, and that will work for everything. So we've got 7 of them in total there. 28, a logic one here. Snake lies Monday, Tuesday, Wednesday. Tiger Thursday, Friday, Saturday. When you're doing questions like this, just try going through the answers and seeing which one makes sense. So on Thursday, let's pretend it's Thursday. The snake is lying. Sorry, the snake is telling the truth. The snake tells the truth on Thursdays. So the snake says, yesterday was my lying days. Well, that's the truth. Yesterday is Wednesday. That's the lying day. So that's the truth. Now, Thursday is one of the tiger's lying days. The tiger says, yesterday was one of my lying days, which is a lie. It wasn't, because Wednesday is a truth day. So Thursday is the answer. And just to show you what it looks like when that's not the case, if you were to pretend it's Friday, on Fridays the snake tells the truth, but the snake says, yesterday was my lying days. Yesterday is Thursday, which is also a truth day for the snaker. So that's not correct. That's a contradiction. So that's just what it looks like when it doesn't work. But yeah, just try the options when you get a question like that. I also did it for Monday, but yeah, sure. 23, several points marked on a line. This is one of those questions where you just want to try it out and see and get a feel for it with some smaller numbers maybe. So let's do a line and let's put 4 crosses on it, or 4 points. Now, you're going to mark a point between each pair of points. So here we're going to mark another point here, here, and here. Now what I notice is, for whatever number of points you start with, you're going to mark 1 less than that, because there are 1 less gaps than there are points. And this works here, right? Now we've got 7 points. And so we're going to mark 1, 2, 3, 4, 5, 6 new ones. So whatever n points you start with, you add one less than there was before. So let's start with n points. When we do this adding points in, we add in another n minus 1. So that's starting with n points, we add in n minus 1 in between. But now we have 2n minus 1 points. So we're going to add in 2n minus 1 minus 1. And we're going to add in the number of points that we are currently sitting on minus 1. But now we have 1, 2, 3, 4 minus 1, 2, 3, 4n minus 3 points. So we're going to add in 4n minus 3 minus 1. And we continue in this vein. Now we add them up again and we add in one less than that. And all of that, after we do it 1, 2, 3, 4 times, all of that makes 225 points in total. And this is just some algebra to solve. And you can solve it and you'll get your answer of 15. 24. So we're looking for the angle QPR. Now, what's interesting about this, I guess, is that there's lots of isosceles stuff going on. PS is equal to SQ. The original triangle is isosceles, it should be said. And then we've got PS equal to SQ. So this triangle is isosceles. This triangle is also isosceles, and so is this one. So quite a lot of isosceles triangles going on here. Let's just do some algebra. So this whole angle here is 180 minus x, all divided by 2. Which I can simplify 90 minus 0.5x. That's the whole thing. Okay, but also this angle is x. So that angle there is the whole thing, but this angle is x because this triangle is isosceles here, and these are the two base angles. So this angle here must be 90 minus 0.5x, the whole thing, minus x. So that angle there is that. But of course this triangle is also isosceles, so that's the same here. That's the same angle there. But remember, this triangle is isosceles as well, so this whole angle here also applies to here. So that's that angle, 90 minus 0.5x. But then, of course, this angle is this whole angle take away this one. So 90 minus 0.5x, just this angle here, 90 minus 0.5x minus 90 minus 1.5x. Just speak out of the negatives here, minus minus here, gives you a plus x. So this angle is also x. And then one more isosceles triangle is here, according to the question. So this angle is 180 minus x over 2, which we've already said is 90 minus 0.5x. And finally, this angle here is 180 minus x, so 180 minus 2x. These two angles are on a straight line, so this plus this must equal 180. And you can solve this for x. And remember, x was the thing that we were originally looking for, because it's this angle here, so the answer is 36. Quite a nice little question, that one. There are 2,022 kangaroos and some koalas living in parks, in 7 parks. In each park, the number of kangaroos is equal to the total number of koalas in the others. So let's do some notation here. Let's call K1 the number of kangaroos living in park number 1, and K2 the number in park number 2. And likewise, now this is also K, which is annoying, so we'll just call it T. What I can say also is K1 plus all the way to K7 is 2022. That's just what this information tells me. Now, I'll call koalas T. T1, the number of koalas living in Park 1, T2, and so on, all the way to T7. Now, what this says is in each park, so in the first park, in Park number 1, the number of kangaroos there is equal to the sum of the koalas in all the parks other than Park 1. So K1 is equal to T2 plus T3 all the way to T7. The sum of the koalas in every other park aside from the koala park that you're looking at. And likewise, K2 is equal to all the koalas that aren't in 2, so just miss 2. And keep going along, missing the same number you've got here, so missing the 4, missing the 5, all the way along. And now what we can do is we've done this a couple of times in this challenge, add all of this together. If we add all this together, we get all the K's added together, equals 6 lots of all of the different parks of koalas, because you've got 7 equations here, and each one misses each individual park once. This one misses the first, this one the second, this one the third, and so on. So you've got 6 lots of these. But we know the sum of all the kangaroos, that's 2022, so that's 6 lots of all the koalas. So just divide by 6, and we find there are 337 koalas. Just do a bus stop to divide that by 6, and it goes exactly. Cool, that's the entire challenge. Apologies for just making a small mistake on one of those questions. Really well done if you thought you did quite well on that, or if you just tried it, having not got the opportunity to take it. And thank you for watching.